So there's two levels, really levels of the project. So the first is to look at the subsurface layer, that you have that formation and you want to try and find it. You want to see where it's going. So we're going to look at finding the initial release and the transport. And for that, you want to be able to do a method where if you find oil, you have the highest probability of continuing to find it. Now, what's very different about this project is we understand in the ocean that the rotation of the Earth causes the density surfaces to tilt. So if you just look along a constant depth, you can miss the oil because it's changed its speed. And so we're incorporating that into the search algorithms to use the output from a circulation model and then follow a constant density surface as it moves up and down as we're searching for the oil. Now, for oil that's heavier than seawater, that would be on the bottom. And in the coastal areas along the shelf, the water behaves as very stiff columns. So it's going to follow bathymetry. So it may move offshore or onshore depending on what the bathymetry is doing. And so that's what we're going to incorporate into the search model from where you found the oil to continue finding it as it moves. So we've been looking at a couple of spills. We've been looking at the Deepwater Horizon in terms of how to find the oil, doing estimates using the Oscar model from SINTEF in terms of creating a full simulation and then subsetting that data to see if we can locate from a limited data set, find the rest of the observations. And then in the second part, there's an increase in spills of heavy oils, and that's because there's this new product called slurry oil. So it's a heavy dense product that using cracking techniques can be reduced to a lower viscosity, so it's not so stiff and it's pourable at room temperature. So it's very pumpable and increasing product, or it's a more ship product. The other is people have heard about the diluted bitumen spills, the Kalamazoo River, and that product, the bitumen separates between the toxic diluent and the sticky bitumen, and so that also goes down on the bottom. So we have more case studies, but I think it's a model that would be used more because we are having more of these small type spills of heavy oils that sink.
Okay.
So what we want to do is to be able to sample a spill very efficiently, as well as to take the right types of measurements in order to guide the response teams. That's, I think, where we have the biggest potential effect. For the subsurface, there are more of those types of spills, so we want to be able to have the response teams more quickly find the oil and potentially recover it. With the subsurface layer of droplets, there really isn't an option to recover them, but you want to be able to identify where the oil is and where the potential for the biodegradation to reduce the oxygen and be able to better estimate what that oxygen loss might be. We hope that groups like NOAA or other groups that do spill response will be able to take this open source tool and either work with us or use their own programmers to be able to incorporate it either into their tools or decision support or to be able to develop new tools. So the thing I would add is that most people think about oil spills at the surface. That's where the charismatic megafauna is, birds and other things, dolphins, but they really don't think about the oil that's beneath the surface quite so much. And that is going to be an increasing problem related to spills. We don't want people to hide the spills. You know, we can't see them at the surface, but we want people that understand the spills to be able to find the oil and either recover it or identify where it's going. And with the change in our use of hydrocarbons and the type of hydrocarbons that are being used, I think this is going to be an increasing business for scientists in terms of and responders in terms of looking for the oil and figuring out what to do with it.